We'll be going over operators in Java. We're going to start with simple operators like the minus operator, and then we're going to print for each of the operators an expected output. So first, we're going to do first num, second num, so it's 10 and 22. So if I do 10 minus 22, this should give me, would be a negative number, in this case, negative 12. So simple operators on integers will give me positive and negative numbers. In this case, if I switch them around and I did, something like second num minus second num, I would then end up with 0. And then if I did second num minus first num, I would expect then positive 12. So simple operators like minus and plus will work just as expected when it comes to any math operation that you've done. Let's look over a more specific operator like the minus equals operator. In this case, what it's going to do is that it'll subtract a value and then store that value. Now, for what does that mean? If I have the original score, which is 100, and I said I want some new score, so it'll be original score minus 10, this new score would then print out what I would expect to be 90. I'll go ahead and change that right there. And then I will print for the minus equals operator, it's going to be 90. Now, what if I didn't want to create a completely new variable for the new score? What if I just wanted to update the original score? Then I would possibly try to do something like this, but it's going to give me an error and say you can't do that. What you have to do is that you have to minus equals the score. So you're going to subtract 10 from it, and then you're going to end up making the result be stored in the original score, just like we did right here. So in this case, original score, because I minus equals it with 10, I would expect that to print out 90. So I minus 90 from the original score, and then I make the original score equal to that new value. If I have the minus minus operator, it works similar to the two that we've seen so far. So in this case, I have a variable called age, which is 99, and I do age minus minus. That's going to end up being a new value. So it's going to subtract 1 from this variable, and then it's going to make that variable equals to that. Let's see what happens if we run there. I would expect to be 98, which is that one right there. Now, if I did that many times, it would continue to decrease that variable by 1 every time. So it would 98, 97, 96, and then it printed out 96 over here. Now you could do that that same operation if you wanted to, but if you wanted to increase a number. So we're going to start by looking at integer stickers. So we have 10 stickers, and then we want to increase it by 1. So if I do in stickers plus plus, when I print that, it's going to be 11. So the plus plus operator increased it by 1 and then made that variable equals to that. Now, what if I have a double? Would it increase it by 0.1 or would it increase it by 1.0? Let's see what happens. So in this case, operator double plus plus, we have double shoe size, which is 7.5. We plus plus did, and what's going to happen is that it's going to increase by 1.0, not 0.1. We have a couple of other operators. We have the multiplier operator and the multiply equals. We're going to start off with the multiply equals operator. So if I have pens and I have 100 pens and I have a double of that, and then I multiply equals, it works similar to minus equals in the sense that it's going to multiply this number by 8 and then it's going to store that number in pens. So I'm going to go over to the multiply equals operator and I will run the value for pens, and in this case it's 800.0 because we have a double. Now you could do the same with just a multiplier operator. If you created a new pens variable you multiply the original value times 8, and then you made that whole thing equal to some value and put that inside a new variable. So I would go ahead and print out just the multiplier operator. And in this case, we notice that we first multiplied this and equaled it to 800, and then we multiplied it again. So that's why we got 6,400. So if I comment that out, I would get the expected 800. So we have to be careful with the operators that we use. In this case, I have 800 here, and then I notice that my other operator now doesn't give me the value of 800 that I wanted. Because we took this out, it's only taking 100 and it's not multiplying it by 8. So instead we have to put it in a different line. And in this case, I should get 800 for both. There we go. And then I'll clean that up. Now, if we look at the division operator, we're going to divide some ints first. So if we divide 3 divided by 2, I would end up with some number, which is a mystery number. And let's see what that mystery number would be. In this case, I would get 1. So 3 divided by 2 is supposed to be 1.5, but in this case, I got 1. Because this is an integer, there is no 0.5 in integers. There's just whole numbers. So it's going to truncate that. It's going to get rid of anything point whatever, and it's going to give me the whole number. So it's just going to give me 1. Now, if I did 3.0 divided by 2, I would expect for there to be 1.5 in this case, because doubles do have a 0.5, and we get exactly what we wanted. Now let's look at the division equals operator, which is the same as what we've seen with other equals operators. Is going to divide that number by 2, which is the original number here, and then it's going to make it equal to that. So in this case, we have an integer, we divide it by 2. Toys, we would expect to be 50 when we print it out, and that's exactly what we get. Now let's take a look at the modulo operator. In this case, modulo gives us a remainder. And to be able to demonstrate this, we're going to look at an example where we have a pizza with 100 slices. Then we have a certain amount of people that are going to eat this pizza. There's going to be a certain amount of slices per person, so everyone gets the same amount, and it has to be fair. Even if there's some leftover pizza, if it cannot be distributed equally among all people, we cannot distribute those leftover pieces, and there would be what we have as leftover. So the first thing that we're going to look is slices per person. So slices per person would be the pizza divided by the amount of people. So if we divide 100 pieces and share them among 6 people, then we would have 16. Now, this obviously is not the exact answer, because if we have slices of people divided or multiplied by the amount of people, so if 6 people each ate 16 slices, we're going to end up with 96. So there's only 96 pieces of pizza that were eaten, even though we had 100 to begin with. So what's going to happen? We can get the leftover amount with the modulo operator. So if we did, in this case, the leftover amount, we would notice that the modulo operator would give us what's left over, which would be 4. So if we have 100, modulo 6 is the same as saying divide 100 by 6 and give me what's left over. In this case, we divided 100 total slices by 6 people. And we notice that each one of these 6 people would get 16 equally, and total there would be 96 eaten, so 4 would be left. So the modulo operator gives us whatever is remaining. It gives us the remainder of a division, or what's remaining if everything was shared equally. We're going to look at a couple of operators that help us understand if things are true or false, or if things are equal. So in this case, we have the equals equal sign. So that means is one thing equal to another? And then we have the not equal sign, which is the opposite. Is this thing not equal to the other? So the first thing that we're going to do is we're going to look at some integers. Now, if I wanted to, say, figure out if one integer is the same as the other, I am free to use the equals equal sign. So I will say my age equals Ed's age. So in this case, I would expect the system to print out true. So we're going to go at the bottom, and it's printing out that my age equals Ed age, which is 32 and 32. 32 are the same. What happens if I do a double with an int? So if I do my age with a specific age, then it should, and I will wait for it to reload, specific age. It should then print ideally true, because 32 and 32.0 are equal, and it does. So you can be safe that these two can be used interchangeably. But when we're looking at strings are a little bit more trickier. So let's look at this. My name and my nickname. So they are both equal to each other. And if we notice that I run this and I say my name equals nickname, same name, true. So this right here. Now, what happens if I modify one of those names though? So I go string, my full name is Edwin Lagos, and then I go, well, my first name is Edwin, and then later on I do plus equal. So I add on a new value onto Edwin. So I'm adding on Edwin Lagos. So now these two should be the same. Full name and first name should be the same. But let's see what happens. So I will say our full name, Edwin Lagos, and first name, Edwin, plus equals Lagos, the same. And then it's going to say they are not the same. Now, how come? So in here, strings were able to give me a value that was what I expected, but here these strings are not giving me the value that I expected. So maybe I should check that. Maybe I can print them out and see if I added those correctly and see if these two are exactly the same. And if you look at it, both of them are exactly the same. So how come this doesn't give me what I wanted? It's important to know that equals equals doesn't work as expected with strings. In Java, you have to use dot equals. So you do is the first name dot equals to the full name. And in this case, I would get what I'm expecting. Now, both of them are true.